Today I'm going to be building a noisemaker box. Now, I first started messing around with these circuits when I was a kid, probably around 10 or 11 years old, with the Radio Shack Science Fair 160 in 1 project kit. Now, as I got a little older, I found out instead of using transistors to make these circuits, they had come up with integrated circuits. So I started using op amps and 555 timer IC whenever I built these optical theremins, I call them. Now, over the years, I built a good amount of these things. Made a couple for some friends, and had a bunch of different designs, dual ones with echo in there. I have a little tiny slide synth model that I built. So I'm really fond of this circuit. Now, a little while back, I found out there's this chip I had never heard of, and you know, your typical chip that I would use for this, it has one engine inside of there. This chip that I have here today, it has 6 engines in there. So the idea is, rather than 1 or 2 voices, it's gonna have 6. It's gonna make quite a racket. Now, the interface or the controls for these suckers, I like to use a cadmium sulfide cell or a photoresistor. Now, you can think of this, it's just like your volume control on your TV, but instead of a knob, this reacts to light. So it's a little electronic eye. Depending on how much light or shadow falls on that, that's going to raise or lower the pitch on the unit. So we got our box. It's going to have the 6 cells on there. I picked this up at Salvation Army. It's the Quack Quack duck game, and Quack Quack is going to be reincarnated into the Quack Quack Hex Box. I don't know. I got to think of a cool name for this. Now, traditionally, when you're mixing together, we're going to have 6 channels to combine into 1 speaker or output. You use active or passive mixing, which just combines the sounds. Now, I've heard that if you use a diode to mix sounds together, or diodes, depending on the frequencies at the time, the diode is going to cross-modulate it, or it's going to take bits and pieces of the different frequencies and combine them into something kind of a little different. So I have no idea what this is going to sound like. I imagine it's going to be pretty interesting. And with 6 channels, I've got plenty of options, so I'm probably going to end up maybe going half traditional mixing, you know, straight together with resistors, and then maybe the other half diodes. I really don't know, but I can guarantee you this is going to be an interesting project. So I'm going to start by breadboarding this sucker, and then we'll move on and end up doing a sound test hopefully here tonight. So thanks for watching. So as you can imagine, this is kind of an oddball part, and they didn't carry it at Radio Shack, but I took a look online, and they do have it at Fry's Electronics. So we ran down there, and well, they didn't have it in stock. So I was digging through all of their stuff. They've got a lot of stuff at Fry's, and it turns out they did have, this one was an inverting hex schmitt trigger IC. So anyway, I mean, it was $1.50 for this chip. I went ahead and bought it anyway. And the other thing, it runs off of 5 volts maximum rather than 9. I usually run all my projects off of 9 or 12 volts. So I don't know. I've got a little voltage regulator chip, a 5 volter. So we'll have to see. And as far as that inverting thing goes, well, I got my fingers crossed. So I thought it would be interesting for me to take a look at my notes, and you could get a better idea of what's going on inside of this chip. We've got pin 7 is going to be our negative, or the ground. The power comes in on pin 14, and then on every other pin we have, you could think of those triangles as an amplifier. So what we got going on here is, this is a capacitor, and that's kind of like a battery. It fills up with electricity and discharges, and that's kind of what creates the on-off to make it produce a tone. You've got, this is the amp's input. The output comes out and goes right back in. So we are torturing this amplifier. We are making it feed back to the point where it's screaming to produce a tone. That is being controlled by our variable resistor, and that is setting the pulse. So torture time times 6.
Okay, well, I've made a decent amount of progress. I went ahead and got the circuit laid out, and it's working pretty good. Right now I'm using half diodes, half resistors. We'll have to see about that. Now, what I want to do is make this have a built-in speaker. So I got this for $1. It's some kind of kiddie toy. Remove the LEDs. It's a little amplifier circuit. We're going to use that to power our speaker, but I'm also going to have a output jack in it so you can run it through an amplifier or record it, you know, with a, so you got an output jack on it. And so you'll have the amp running the speaker. Once you plug that in, it bypasses the amp. And then circuit here, you can see the layout, how I'm going to put the light sensors in here for the fingers, and then a couple down here. So it's coming along pretty good. Just got to